everyone. This is obviously the Advanced Higher Classes lesson on Pearson's product movement correlation coefficient. This is statistics lesson 8. Well done for making it this far. If you have watched the linear regression lesson and have been subsequently traumatized by that, then please don't worry. Pearson's and the next lesson, the last lesson, Spearman's, are a cakewalk in comparison. So you're over the difficulty curve. In this lesson, I'm going to show you a statistical test that allows us to see if there is a relationship between two sets of interval data. I'm going to give you a worked example of Pearson's. We're assuming in this example that it's a river study undertaken by advanced higher pupils, and we've decided to test whether the gradient of the river, the steepness of the river, was having an influence on the pebble size, which, by the way, you should refer to the classed size, C-L-A-S-T. You should know that Pearson's can only really be done with interval or ratio data. You should also remember from lesson 1, if you've forgotten these terms, you should review lesson 1. So go back right now, stop playing this and go and play lesson 1. You should know that ratio data is the one that we don't use so much of, and interval data, you do need to know what that means, so go and review lesson 1. I'm not going to go through it again now. So, we have gone to our study sites down the river, 1, 2, 3, 4, 5, 6, 7, 8, etc. And we've measured the gradient to each of those. And we've measured the average, the mean size of our pebbles. We need a hypothesis. Well, my H1, my working hypothesis, my alternative hypothesis, whatever language you want to use, is that class size is related to the gradient of the stream channel. So you should all therefore, by this point, know that you have to write a null hypothesis that says there is no relationship between the class size and the gradient of the river's channel. Again, I shouldn't really have to point this out. You should be taking notes. You should be writing all of this out, taking copies, and working through the problem as I take you through it. It's far more beneficial than just sitting and watching. If you're just sitting and watching, you're really wasting your time. We need to set the data out into a table like this. Now, I've got worksheets you can borrow, both digital and paper, that will allow you to quick step this process. So if you want copies of those, just ask, and you can just copy and paste the table into place. But honestly, if you've got Excel, which I know that you all have access to, then just simply write these words into some cells in Excel is really easy to do. Right, let's get some basics out of the way. Please notice that there is a small x and y and a capital X and y. These are different, and they refer to the original data that we gathered, gradient and mean pebble size, and they refer to the bar x and bar y values. Okay? Just be aware of that. Big X is not the same as small x. Big Y not the same as small y. Alright. First step. I need you to sum, remember that means add up, x and y, and in each case work out their respective means. So, we add up all of these numbers and we get 14.5. I take 14.5 and I divide it by n, which you should know by now is the number of rows in the table, and we get 1.81. Add up all these numbers, you should end up with that figure, divide by the number of rows, and you should end up with that figure. Okay, so that's so far so easy. Next, we fill in the next column along. X minus bar x. So we're going to take x and take away the bar of x. 1.1 minus 1.81 is minus 0.71. We're going to do this for both the big X and the big Y columns. So Y minus bar Y. Y, 2472, take away bar Y. If you've forgotten, bar Y means the mean of Y. And if you've forgotten what mean means, then you need to go and review lesson 3. Do that for all of the numbers. Then we work out the next two columns along. These are big X squareds. So this is x minus bar x squared. Well, we've already worked out x minus bar x. It was minus 0.71. And so we square that. The reason we're doing this, for all you maths fans out there, is to get rid of the negative values. If you are not a maths fan, and therefore a normal person, then just do it because I'm telling you to do it. You can see that I've done that for both of these columns, and instead of just passively watching, I actually want you to do these calculations so you can get a sense for how this process takes place. At the very least, you'll get an understanding of how long it takes you to do this process, and you may be actually pleasantly surprised. A lot of advanced higher pupils are put off doing these tests because they think they're hugely time consuming. But if you learn to lay the tables out correctly, and to enter the data correctly, and to just do it systematically, you'll find that really this doesn't take that long. And a Pearson's test can be quite a simplistic thing to do once you have practiced the whole thing through from beginning to end. So please make sure you are writing this out as I show you how to do it. Okay, and assuming that you've done all that, we now work out big X times big Y. So that's x minus bar x times y minus bar y. We already know x minus bar x, we already know y minus bar y, so we do minus 0.71 times minus 3,595.13. Whew, that gets us these values. Brilliant. Now what you do is you sum the x squared, the y squared, and the xy columns. That means add them up. So we add up this one, we add up that one, and we add up this one. You can see that some of the numbers you're getting here are really quite large, and therefore a regular calculator might not be able to handle it. You might need to get a scientific calculator. By the way, if you do not have a scientific calculator, don't feel you've got to go out and buy one. Almost all, in fact, all computers have a scientific calculator built into them. If you just do a search function in whatever kind of tools you've got in your laptop or wherever you're working, you'll find you've got a scientific calculator. All right. One can use one of 3 different equations, which is a little bit annoying, but they all come to the same thing. So if you're looking in some other teacher's notes, or another textbook, or a different website, or who knows where, please be aware that the Pearson's calculation gets laid out in a number of different ways, alright? I like the one that's easiest, so we will be using this one, alright? But it really doesn't matter which one you use. So, let's get to it. We need to replace the letters with the numbers. We need to do the sum of x, y. Well, we know that we know what the sum of x, y is. You can see it right there. It's down here. Because remember, this column of the table was the xy column, and that value was 9,609.69. So I've put that up here. I've put all the important numbers up here, but I just want to make you aware that these terms are found within the table, most specifically in the bottom row of the table. So we would do sum of xy, well that's 9609.69, we do the sum of x squared, which is 4.37, times the sum of y squared, which is that huge number there, which I won't read out. And once we have that, we need to square root it. We then divide 9609.69 by the value that we get by multiplying this with this and square rooting it. That will end up looking like if you want it in numbers, that's what the sum looks like. So you can go ahead and work that out for yourself. And you should find that you get a simplified version that looks like that. And of course then we just work out the final R value, which is 0.551. What you do now is you take your R value, 0.551, and you look it up in your critical values table. Now the degrees of freedom are important. To work out the degrees of freedom, you take n, which remember is the number of rows in the table, minus 1. So in this case that would be 7. We go to the 7th row on your critical value table, and we look at what the score would be. I won't keep you in suspense. Our working hypothesis was that pebble size is related to the gradient. The result of 0.551 lies below the 95% significance value of 0.666. Therefore, we must reject our working hypothesis and accept the null hypothesis that classed size, remember that means pebble size, is not related to the gradient of the stream channel. And we have then analysed that hypothesis. Okay.